Hello and welcome back everyone to SpaceSim, not to be confused with Space Simulation Toolkit, different game. This was made by one of the guys, I believe, who worked on Universe Sandbox 2. Awesome dude, makes a lot of good software. But today we are going to be simulating Earth hitting a immovable wall, that is the purplish plane you can see in the distance, at high speeds with 1 million particles. That's right. I really baked my graphics card for this one, and my electric bill is going to be higher than usual. But let's see what it looks like. I love this simulator, it's so good. It is on Steam now if you want to support it. I think it's like 15 bucks, but SpaceSim is absolutely fantastic, and if you've never seen it before on this channel, you'll see why it's fantastic. It has some of the best soft, like, deformation physics out of any... Yeah, look at it go! Okay, so I'm gonna pause just so that we can inspect the magnitude. I mean, already, I'm not dead yet. I'm not dead yet. I probably felt that, though, in the ground. You know, the shockwave probably did kill me, but it's okay, I'm not dead yet. I'm around here somewhere on the East Coast. Sorry, California. I can't control it. Yeah, so Earth is deforming rather quickly. It has slammed into the wall. Worst off for, actually, mostly the Pacific Ocean. Sorry, China. Sorry, Japan. India's about to see some pain. Looks like Africa won this one. They're going to be the last to slam into the wall. But man, so cool. And the best thing about this is that you can scrub, so I can actually just reverse time and play it forward and back over and over again so that you can see the beautiful destruction. I know. Isn't that neat? Alright, let's go ahead and play this back again so we can see the destruction. Interestingly, there is a point at which, like, it's flat. Like, the material is just kind of being pushed against existing material, so it's kind of just, like, flattening out. And so, for just a moment, flat earthers are correct. You know, this is looking pretty flat. Even though the edges of the world are kind of destroyed and there's no ice wall. I mean, Europe's still kind of good, and now it's just stretching. Like, it's stretching out because all of the force is going out along this plane, basically horizontally if we were looking like this, and stretching. Pretty much all of the features of Earth have been kind of ripped apart at this point. And you may be wondering, Spike, isn't this the end of the simulation? No, that's the cool thing about this, because there's still gravity and things still happen after the destruction. So you'll notice that there's these clumps of Earth, which are just kind of sticking together due to gravity. And as time goes on, we're gonna notice kind of spaghettification as these little tendrils of gravitationally attracted material, like this right here. I don't know if you can really see my mouse in this. Are forming these beautiful tendrils, and we got some groups of material, some holes now appearing where all of the material is actually absent because it is forming into these like tubes that looks like neurons. But one of the really neat things is that, like, this is all happening on a single plane. Like, we've effectively made a two-dimensional simulation because everything except for the tiny bit that's bumped out here is just like on this plane, and so all the gravitational forces are pretty much also on this plane, and so three-dimensionality has kind of been eliminated. Oh, also I lied, it's not a plane, it's actually a cube. This has ramifications because it means that the stuff being ejected to the side are actually going to hit the other edge of the simulation as well and form these kind of lines of material. But you can definitely see the spaghettification, like, very, very effectively forming here. And now, at the crossroads between these spaghetti, what would you call a single spaghetti stick? Strands of spaghetti, where they intersect, you're gonna notice that the gravity is actually forming like little asteroids and planetoids. Because it is the most concentrated bits. So, like, at every single one of these nodes where you have a bunch of these little spaghettis connected, it's actually pulling in enough to form new little planetoids. Now it really looks like neurons, kind of creepily so. Did you know that the universe, like, when it expanded and formed, it actually, like, really closely resembled neurons? It's something that freaks out, you know, people who look at it, because it's like, maybe the entire universe is conscious. Probably not that far, but it is a neat, like, physics thing that shows up on the very macro large and the very tiny small networks. You get these beautiful node structures with these tendrils. Yeah, and so now we have a ton of these microplanets that have formed, or protoplanets, and we've got the edges, and we're just gonna scrub forward because it slows down, less energy. But as time goes on, you can see that these protoplanets, look at how many, like, tendrils there are, and then they slowly disappear, they get stronger, and now we can see the little protoplanets are beginning to collide. So, like, this one's a big one. We've got 3 right here. Then they're going to happily merge into an even bigger one, and they're just going to continue gobbling each other up. Because even though Earth is gone, there is still hope. I like how it's still labeled Earth, because it's still got a little bit of mass. There's just one thing. I'm gonna get rid of labels. There's just one thing left that's labeled in the whole universe. Okay. So what is left of Earth is actually just going to consume. Unfortunately, most of the energy has been consumed at this point. Everything's moving very slowly now as it kind of recombobulates, and we've gotten to the end of the portion that I have simulated, ending up with these very, very interesting little protoplanets that remain. In the corners we have stuff too, because the corners are kind of places that all this material naturally kind of formed up. And actually, over a long period of time, you can see that very slight velocity in the Z direction. I'm just gonna call it the Z direction. I don't know if it's actually the Z direction. We're going with an traditional Y, X, Z axis, unless you're an animator, in which case you're gonna fight with me and say that Y isn't up and down, but you're wrong. You're wrong. Y is up and down, because Y goes up and down. Okay? I'm sorry. This is just how it is. Z is depth, okay? Fight you. Anyways, yeah, there's a lot of these little gases that have kind of spread out throughout the entire box at the end of the simulation, which weren't really that far forward at the beginning of the simulation. Actually, you can really, that's interesting. So you can see that it hits the first plane, then the material hits the edges, and then that causes them to refract out, and then that eventually hits the corners here on the other side, and then we basically have the full 3 dimensions filled. It's pretty neat. Pretty neat. I think the coolest part is definitely the spaghettification phase, like right here. It's just, it is gorgeous. Just the amount of order that comes out of the chaos is just really, really neat to see. The Spaghettitron. I wonder if we can get like a really, just gonna see if we can get a better like view of it, but those little protoplanets really, really do a cool job. And we can scrub all the way back to when Earth still existed. Let's look at it from the other side. We haven't really looked at the simulation from the other side, the side that was doing the colliding. Sorry, Australia, I forgot about you. You were wiped out so quickly that I just forgot you exist. Oh man, those first few moments actually. Do you see the shockwaves? Like the instant concentric shockwaves just occurring like everywhere at once as the material gets pushed. And then you get that like secondary kablam as it kind of collapses in and back out again. And then the force is just overwhelming. I mean, yeah, it would be a bad day if you were Australian. Probably not your best day. But overall, I think I love SpaceSim. I'll do some more things. I'll cook some more simulations on it. There's a lot of things you can do with it. You can even customize like how it looks. You can change the settings to make things more aesthetically pleasing. Hey, look, I can affect the amount of bloom. Oh my goodness, it is so bloomy now. That looks kind of cool, actually. Oh, the bloom. Oh, the bloom. Doesn't look ridiculous at all. Maybe I should start recording my videos in HDR for those of you with HDR monitors, because man, does it look good. It looks right. You can probably see the red reflecting off of my face because of how bright this is on my monitor. Like when I zoom in. Yeah. It's good looking. It's good looking. You got like diffraction. Yo. Compression. Yo. Yeah. So you can make it look really cool. I'm not going to drag this on too much longer, but that was a really cool simulation. Thank you for making SpaceSim. Thank you, developer. You've given so much to the world. Thank you all for watching. Leave a like and subscribe if you enjoyed, and I will see you all next time. Just make sure you do not get stuck in the cosmic cube of destruction.